Welcome back to the third session on effect measure modification. In this session, I'll essentially summarize how we address third factors in epidemiological studies. Up till now, we've talked about two phenomena in which third factors can play a role. One is confounding, where the third factors confound or bias the effect of the exposure on the outcome. The other is effect measure modification, where the third factor actually modifies the effect of the exposure on the outcome. Now, is it possible that a same factor or a same third factor could act as both a confounder or a modifier? Let's look at this example here. Here we are interested in understanding the effect of smoking on cervical cancer, taking race as a third factor. It is understood in literature that race can influence cervical cancer by itself. It's an independent risk factor of cervical cancer. Here by race, we are taking the black and white. And race also has been shown to have an influence on smoking rates. The smoking rates are different in blacks and whites. And hence, it could be a potential confounder. Race could also be thought of as a modifier in that it is possible that the effect of smoking on cervical cancer might be different if you are black or white. To really know whether race could be a modifier or a confounder or both for this study on the effect of smoking on the cervical cancer, we took data from 4 different studies done in 4 different source populations. So here the total column at the end reflects the crude analysis, the risk of cervical cancer among smokers and the risk of cervical cancers among non-smokers in each of the 4 source populations. Then in the middle, there is the stratified analysis, but stratified by the risk of smoking on cervical cancer among black and among white. So let us look at the result of this analysis. If we calculate the crude risk ratio for each of these source populations, in the first source population, the crude risk ratio would be 1, right? That is 16 divided by 16. In the second population, the crude risk ratio is 1.64, that is 22 divided by 13.4. In the third, it's 1.43. And in the fourth is 2.44. So as such, it seems that the smoking is a risk factor for cervical cancer in populations 2, 3, and 4, but not in 1. We also calculated the risk ratios for the 2 strata of black and white for each of these source populations. And then we calculated the adjusted or the standardized risk ratio for each of these populations. So in population 1, the adjusted risk ratio is 1. Here it is adjusted for the effect of smoking. In population 2, again it is 1. In population 3, it's 1.43. And in population 4, it's 1.67. Now, based on this information, and then we also have the stratified risk ratios, the risk ratios among black in the 4 source populations, and the risk ratio among white in the 4 source population. Now, in order to identify whether race here is a confounder or not, we would actually compare the crude risk ratio with the adjusted risk ratio. And if we find that there is a difference between the crude and the adjusted, then we can infer that yes, race is a confounder. Otherwise, it is not. In order to know whether race is a modifier of the effect of smoking on cervical cancer, we would actually compare the 2 stratum-specific risk ratios, which is the risk ratio amongst black compared to the risk ratio among white. So in the first source population, the crude risk ratio is similar to the adjusted risk ratio, and hence race is not a confounder. Is it a modifier? Again here, in the first source population, the risk ratio in the blacks is 1 and the risk ratios among the whites is also 1. So the stratum-specific risk ratios are also similar to each other, and hence we can conclude that race is not a modifier as well. However, if we look in the second source population, we can see that the crude risk ratio of 1.64 is different from the adjusted risk ratio, which is 1, and hence we could label race as a confounder. However, the stratum specific risk ratios between black and white remain the same, and hence is not a modifier. Opposite to that, in the third source population, we can see that the crude and adjusted risk ratios are similar. However, the stratum specific risk ratios, the risk ratio in black and white, are different. It's 2 in the black and 1 in the white population. And hence, we can say that in this study and in this source population, race is not a confounder. However, it does modify the effect of smoking on cervical cancer. And finally, in the fourth source population, we can see that it is both a confounder as well as a modifier, because the crude and adjusted are different, as well as the two stratum specific risk ratios are also different. So what we're trying to say here is that it is not necessary that if a particular third factor or a particular extraneous variable is a confounder, it cannot be a modifier, or if it's a modifier, it cannot be a confounder. Any of the combinations is possible in that the third factor can be both, can be neither, can be both, and can be either a confounder or a modifier. For the purpose of simplicity, we have not looked into the statistical difference here, but this is just an illustration to show that how a third factor could behave as a confounder and a modifier, and how you would go about identifying each one of these. So if we have to summarize, basically, how do we take into account whether a third factor is a modifier or a confounder? Essentially, we have to start when we are designing the study or writing the protocol with thinking about what could be the potential confounders or the potential modifiers for our exposure and outcome of interest. And that would be based on a good review of literature and a good understanding of the study population or the source population in which the study is being designed. Once we have a certain list of these potential confounders and modifiers, we would want to collect accurate data on them along with data on the exposure and the outcome. And then we follow the various steps that we have listed before in order to identify that particular third factor, that particular extraneous variable is a confounder or a modifier. You conduct the crude analysis, estimate the crude risk ratio or odds ratio. You do a stratified analysis. If you are looking for effect modification, you compare the stratified measures of risk ratios and odds ratios. If they are different from each other, yes, that particular third factor is a modifier. Otherwise, it's not. If it is, you report them and you do not need to adjust for that modifier, because modification is a natural process. It is something that naturally happens in nature, and we would like to report it and see how it makes a difference in terms of the effect of the exposure on the outcome. While trying to identify confounders, we would want to again do a stratified analysis, and then whatever confounders are identified, we actually adjust for them or control them through adjustment, through regression models as we talked earlier. And so we would report an adjusted measure of association, which is adjusted for the particular one or more than one confounders that may have been identified in the study. So finally, what we would want to do is, in any analytical epidemiological study where we're trying to know the cause and effect, we would, in order to describe effect modifications, our analysis, our whole design of the study must be so that we should look for the occurrence of effect modification, if it's present or not, and report it as it is. However, of course, we would also want to look for confounding, because confounding factors would always be present for, especially in observational analytical studies. But here, the analysis should be such that we eliminate the effect of the confounder, we adjust for the confounder, and we report the adjusted measure of association. Thank you.